No, it doesn't mean that. It just means that
I didn't know half the things on that quiz, so
that's okay. It just shows that you probably didn't have a lot of air, a lot of chemistry or something of this sort. So mixtures. I guess I can't do this anymore. Pen's not working. So let's talk about a pure substance. You guys remember seeing this on the quiz? Pure substance or pure mixture or whatever, whether it was pure or not, homogeneous or heterogeneous. Right? These words sound familiar. So a substance containing only one type of atom or molecule is a pure substance.
Could you repeat that?
Yes. A substance containing only one type of atom or molecule is a pure substance.
So this is the homogeneous.
Actually, no. This is just pure.
Pure? Okay.
But as we know, most matter around us is not pure. It's a mixture of things like the air, like wood and dirt. So we have classifications for this. It could either be homogeneous or heterogeneous. So a homogeneous mixture is uniformly mixed on an atomic or molecular level. And they are usually called solutions. It's uniformly mixed, meaning that if I have like a bottle of water, you don't see anything else floating in there, right? Or like this is homogeneous, meaning it's one, it's the same throughout.
Oh, okay. So wait, what was the definition again?
Uniformly mixed on an atomic or molecular level. You understand that, right? For example, air. Air is a gaseous solution, right? You can't see it, but we know that it consists of nitrogen, oxygen, water molecules, and we know that, but you can't see it. But it's
there.
Uniformly mixed. And another example is brass. If you look at brass, it's actually made up of copper and zinc, but you don't see you don't see separate parts. Like with this pen, you don't see.
Oh, you just see one.
It's just one thing throughout.
Oh.
Right?
Solutions.
Oh, it's called solution.
It's called solutions. And brass is an example of a solid solution. Now, the other one was heterogeneous mixtures. Heterogeneous mixtures are not uniformly mixed, meaning you can see separate. For example, oil and water, right? It's obvious that you could see the oil and you could see the water. You see two different layers.
Also,
Right.
like when they have the glass and then they have different liquids inside. Sometimes
Yeah,
it's
you
like
see them separated. That's an example of heterogeneous because it's not just, you don't see fluid throughout or consistent. Another example is salt and pepper. You could see the salt and you could see the pepper. A chocolate chip cookie, right? You can see the chocolate and then you can see the dough. Or those of you who like Twix candy bars, you have the chocolate layer, you have the caramel, and then you have the wafer. That's an example of heterogeneous. Okay, so anybody have any questions on that? Okay, so all these substances, whether heterogeneous or homogeneous, can be separated, whether by a physical or a chemical aspect. So you remember when I had whether this is a physical change or a chemical change?
Mm-hmm.
So now we'll know the difference between a physical and chemical change. Okay? That's the physical. So for physical change, it's any change in matter that does not change the type of the atoms or the molecules. Like
So
it maintains the integrity of that.
So if it's broken down, then it's a chemical change.
Yeah.
Okay.
Once it changes the substance or the molecule, once a change occurs, it's a chemical.
Can you repeat the definition?
Physical change, any change of matter that does not change the type of atom or molecule within the matter. Can you understand my handwriting?
Yeah.
Okay,
So Louise.
I think y'all got this, but just in case. So this is usually a change in physical properties. Can anybody name a physical property?
Physical appearance.
Okay, like size, shape, and density. These are physical properties. So once these things aren't changed, that means that a physical change had to have occurred. But if this did happen, then that means what happened? Chemical change occurred.
So physical change is what?
Is when
Size, shape, or density.
It stays the same?
Yeah.
Okay.
Like, for example, let me give you an example as water. Like, let's start with actually the solid state. Ice. If you melt ice, a change occurred, but that's a
physical change.
exactly
Because
the mass is the same, the density is the
Shape is
same.
different.
oh, so it's
Just-
based on the size, the shape, and the density.
Yeah, physical
Okay.
changes like
Okay.
physical properties.
A chemical change that changes what it's made up of.
Yeah, well, I'll get more into that so you understand the difference. But everybody understands what a physical change is.
Yeah.
Mhm.
Like these things, the physical properties stay the same. It doesn't like
Changes.
yeah, it
shape
doesn't
and
it
size.
change yeah.
But if it does,
Changes
then
the
it's
appearance, but
chemical.
not what it is.
Exactly. The chemical makeup stays the same.
Mhm.
Now for a chemical change, molecules split or combine together to make other types of molecules. So my triangle type thing is going to represent the hydrogen, and the oxygen is going to be the circles, right?